In this video, I'm going to explain some of the basics about atoms and how they're put together. So atoms are made primarily of three main parts. There are protons, and each proton has a +1 charge. There are electrons. Each electron has a -1 charge. And there are neutrons. Neutrons do not have a charge. Now, if we're talking about neutral atoms, not ions, then our number of pluses and our number of minuses have to be equal so that our overall charge comes out to be 0. So our protons are pluses, our electrons are minuses, so these two parts of an atom have to be equal if the overall charge is going to be 0. So number of protons equals number of electrons. The way we figure out the number of protons, if it's not given in the problem, is that the number of protons equals the atomic number of an element, and you can find that on the periodic table. For example, if we look at this periodic table and we look at nitrogen, we can see that there's a little 7 upper right hand corner, and this is the atomic number. Elements are arranged by their atomic number in our modern periodic table. So hydrogen is 1, helium is 2 on the top row. Then we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, etc. So they're all in order by atomic number, left to right, the way that we read, top to bottom. So if we look at boron, its atomic number is 5. So let's use boron as our example, which has the symbol B. It has 5 as its atomic number, so it has 5 protons. And that means it has 5 + 1 charges, which means it's going to need 5 - 1 charges to balance out. So remember, our protons and electrons are equal. So boron has 5 electrons also. So if you are given either protons, atomic number, or electrons, you can find the other one because all three of those things are equal. Electrons equal, protons equal, atomic number. An atomic number we find on the periodic table. That leaves us neutrons. We'll get to neutrons in a minute, but first we want to talk about where these things are in the atom. So an atom has a nucleus in the middle, and all of our protons and neutrons live in the nucleus. So if it's boron, we need 5 protons spread around in the nucleus. However, protons are all positive. A positive charge does not want to be next to another positive charge. Therefore, we need some buffers in there, something to stabilize the nucleus, something to separate the protons and keep them from touching each other. So we're going to need some neutrons in there. So we're going to have protons in the nucleus, and we are also going to have some neutrons in the nucleus. And these neutrons are going to help spread out the protons so they don't have to be next to each other. outside of the nucleus, in these electron clouds, but they're easier to visualize as rings, even though they are not rings, we're going to have electrons. Now we said that there were 5 protons in this boron atom. And if there's 5 protons, there has to be 5 electrons. The first ring in a Bohr model can hold 2 electrons. The next ring can hold up to 8. So our first 2 are here, and then we need 3 more. So that's a total of 5 electrons. So it's neutral. Our number of protons and our number of electrons are equal. However, how many neutrons should we put in our drawing? I just randomly drew in 5, but maybe it has more, maybe it has less. Atoms can have different numbers of neutrons, and these are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. And this is going to affect the overall mass of the atom. Now, here's the deal. Protons, remember there are positive pieces. Protons have a mass of 1 atomic mass unit. AMU stands for atomic mass unit. Electrons, remember we said the number of protons and the number of electrons is equal. Electrons are tiny. It would take almost 2,000 electrons to weigh as much as 1 proton. So since they're so tiny, we say that they have a mass of 0 atomic mass units. That's not really true. They do have a mass, it's just so little. It's like if you weighed an elephant and then you weighed the same elephant with a fly sitting on its back. Would the fly matter? Not really, because the elephant weighs so much that the fly is just a teeny tiny part of that. So we would ignore the mass of the fly. And we get to ignore the mass of our electrons. Neutrons, our neutral particle, our peacekeepers, have a mass of 1 atomic mass unit. They weigh almost exactly the same as a proton. They're just a tiny bit heavier, but it's, again, such a small difference that we're not going to worry about that. So that means that the mass of our atom, since electrons are 0, the mass are the protons plus the neutrons. So we ignore electrons when we're figuring out the number of neutrons. So for our boron atom, let's say that our atom has a mass of 11 atomic mass units. We would write that like this: boron dash 11. That 11, that number right there, is the mass in atomic mass units of 1 atom of this isotope of boron. Now, electrons don't weigh anything, so that has to be the protons plus the neutrons. So our protons plus our neutrons equals our mass. Remember, we looked on our periodic table and we found boron, and it has atomic number of 5. So that means that its number of protons is 5. We are trying to find the number of neutrons, and when it's written like this, that tells us the mass is 11. So we are going to subtract 5 from both sides, and that will get the 5 off of the side, and we'll just have the neutrons, and 11 minus 5 is 6 neutrons. So we have 5 protons plus 6 neutrons equals a mass of 11, because each proton and each neutron, each one has a mass of 1 atomic mass unit. Let's try some practice problems. In this first problem, we are given lithium 8. Lithium is the element, 8 is the mass. So we can immediately put this 8 right over here, 8 atomic mass units. Now to figure out all the rest, we're going to have to go to the periodic table. But don't get the mass from the periodic table. Remember, our mass for these are changing because our numbers of neutrons are changing. So we do not use our periodic table for our mass, but we can use it to find our protons and electrons, and then we can use math to find our neutrons. So first we find lithium. It's over here, and its atomic number is 3. That tells us the number of protons. Remember, protons are plus charges. So we have 3 pluses. Electrons are negative, so we're going to need 3 of them to balance out our 3 pluses. We need 3 minuses. Remember, electrons don't have mass, so we're going to cover those up. And we're just going to worry about mass and protons to find our neutrons. Now we know that these two things, protons plus neutrons, have to equal our mass. So 3 protons plus our neutrons, however many of those we have, has to equal our mass of 8. So N is going to be 5, because 5 plus 3 is 8. Let's look at another example. In this example, let's say we are given the proton number or the atomic number. And let's say that number is 16. And let's say we're given the neutron number, and that number is 15. So these are our 2 givens for this problem. Well, 16 is the number of protons. That's also the atomic number. So we go to our periodic table and we go till we find 16. 16 is sulfur, this S right here. So it is going to be sulfur is our element. Now, if it has 16 protons, 16 pluses, it needs 16 minuses. Protons and electrons are going to be equal. And then protons plus neutrons gives us our mass. So 15 plus 16, that's protons plus neutrons equals mass. And this equals 15 plus 16 equals 31 atomic mass units. So this atom is sulfur 31. Let's say for our next example, we have sulfur 33. These two are isotopes. Sulfur 31 and sulfur 33 are both sulfur. What differs is their mass, and what makes their mass different is the number of neutrons. So if we look on our periodic table, sulfur is still 16. Pluses have to equal minuses, 16. And to find our number of neutrons, remember, protons plus neutrons equals mass. Protons is 16. We're finding neutrons, and our mass is 33. 3. So 16 plus 17 equals 33. When we were given this, we could have immediately said our mass is 33. And our number of neutrons is going to be 17, because protons plus neutrons equals the mass. Let's try another one. Let's say we know that the number of electrons is 12 and the number of neutrons is also 12. And we have to find these three things. But remember, our protons and electrons are equal because our pluses and minuses have to be equal. So if our electrons are 12 minuses, we need 12 pluses to balance it out. Our mass is proton plus neutron. So 12 plus 12 is 24. To find the element, we're going to use our number of protons. That's our atomic number. And we're going to find number 12. Number 12 is magnesium, Mg. So this will be magnesium, Mg, and our mass was 24. So to recap, protons are going to equal electrons, pluses equal minuses, all the way down our column. Our mass is protons plus neutrons, so 3 plus 5 is 8. 15 plus 16 is 31. 16 plus 17 is 33. 12 plus 12 is 24. These two columns, P and N, have to add up to give us our mass. If we're not given what the element is, we're going to use our periodic table and use the atomic number to figure out what the element is. And remember, the atomic number on these neutral atoms is going to be the same as the number of protons and the number of electrons. So that tells us where to look on the periodic table to find the symbol. Remember, in our nucleus, we have protons, and as separators between them, we have neutrons. And our electrons are out here, outside of the nucleus. Protons and neutrons make up our nucleus. So our nucleus is a positive charge, and positive how many is just however many protons you have. This would be a +5 in the nucleus, which means we should have a -5 electrons outside the nucleus. Each proton weighs 1, and each neutron weighs 1. So the things that have mass are in the nucleus. Remember, protons plus neutrons equals mass. So the nucleus has all the mass. If we know how many protons and neutrons we have, each one is one atomic mass unit. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9 as its mass. 9 atomic mass units. Just add up your protons plus neutrons. To figure out what element, you just look at the number of protons, and remember 5 was boron on the periodic table. I hope this has helped you understand atom basics, and I hope you will check out some other videos down below in my description when you need help with other concepts in chemistry. Have a great day.